children that I forced to learn math. I hope you're having a good day. I will be back tomorrow, so I will see you all then. But for today, let's go ahead and do some math via video. So our lesson is 6.12, reasoning about solving equations. You do have homework tonight, 6.12 homework on GoFormative, just like always. Our learning targets, don't forget to write that in your notebook. I can write and solve an equation that describes the weights on a balanced hanger. So we have been writing and solving equations. The only thing that is different is now we're looking at them on a balanced hanger instead of on tape diagrams. So let's go ahead and we're going to look at the first part, warm up. What do you notice? What do you wonder? So we have some socks on some hangers. What do you notice and what do you wonder? Pause here, get something down, and come back when you've got something. Okay, so just going to start throwing some stuff out there. I'm going to start with my notices and then move to my wonders. I noticed that there is a pair of pink socks and a pair of blue socks. I noticed that they are on hangers. I noticed that the pink ones are balanced. I noticed that the blue ones are not balanced. That means the pink ones have to weigh the same, and something with the blue ones means they are not weigh the same. I also noticed that the blue ones, this one looks stretched out and kind of looks like there's something at the bottom of the sock. I noticed that they are very small socks. Okay. Now let's go ahead. I'm kind of out of notices. So I'm going to go ahead and move on to my wonders. I wonder, why are there socks on hangers? I'm probably going to say that one 2 more times because it doesn't make sense to me, and I'm the person that is teaching the lesson. Okay? I wonder what is in the blue sock. Okay? What did they put in the blue sock? For it to weigh more. I wonder who hangs up socks? And who hangs up socks on pant hangers? Okay, that's a hanger to hang up pants. Why are we putting socks on it? I wonder, how much does that blue sock weigh now? Okay, anyways, I don't have much wonders beyond why are there socks on hangers. Okay, let's go ahead, get something down. I don't care what you get down. That's not as important as next slide, which is still part of the warm-up. Okay, so we have 2 hanging diagrams, except now we have shapes on them, which is kind of more what we're going to be doing today. So first hanging diagram, we have a triangle and we have a square. They are not balanced, obviously. The triangle's hanging lower, the square is up in the air. The second diagram, we have a triangle, 3 squares, and a circle. This is balanced. That means they are the same. Okay, so let's go ahead and move on to what we're actually asked. Go ahead, and it doesn't have to be for each diagram, but come up with one thing that must be true. One thing that could be true, okay? Like, it could be true. Like, we can't prove 100% that it is true, okay? It's just kind of possibility that it's true. Don't have proof that you're wrong, too, okay? And then one thing that cannot possibly be true, it is 100% false. Pause here, try and come up with something, and come back whenever you're ready. So one thing that must be true. Stop. I'm going to start with the first diagram. The triangle is hanging down, and the square is up. That means that the triangle is heavier than the square. So I'm going to say the triangle is greater than the square. Okay? On the second diagram, one triangle is balanced, which means it is equal to 3 squares and plus, oh, no, go back, plus 1 circle. Okay? Those are equal to each other when we put them all together. Now, one thing that could be true, but we don't have proof that it is 100% true or proof that it's actually not true. Okay? There's infinite number of possibilities. What I'm going to do is I'm going to assign numbers to my shapes. So I'm going to say that the triangle could be worth favorite number today, 10. Again, can't tell me I'm wrong, but there's no proof that I'm also 100% right. Okay, next, square. I don't know. We'll go with 2. Okay, square's 2. Now, if a square is 2, okay, this square is 2, this square is 2, and this square is 2. Yeah, I know. Okay, 2, 4, 6. Altogether, they're worth 6. If it is balanced with the triangle, that's worth 10. That would mean my circle would have to be worth 4. Because then the triangles would be worth 6, or I'm sorry, the squares would be worth 6 altogether, plus the circle worth 4 would be 10. Triangle is 10. We are balanced and equal. So again, could be true. Don't know though. Can't tell me I'm wrong. Just can't tell me that I'm right. So, what is one thing that cannot possibly be true? Well, first of all, we know the triangle weighs more than the square. So, the square cannot weigh more than the triangle. It can't be larger than the triangle. Something that cannot also be true would be for a square to weigh the same as a triangle. So, square equals a triangle? That can't be true. So a square cannot be exactly the same or also be balanced. Okay, again, you can come up with tons. I'm just writing some stuff down. Okay, let's go ahead and move on to actually solving equations with these hanging diagrams. So we have 4 hanging diagrams, A, B, C, and D. For each hanging diagram, we are going to match it to one of the equations and then write the variable used in the hanging diagram in the box to make it an actual full equation. Then we're going to solve said equation for problem 2. Let's do A together, and then you're going to do B, C, and D. Okay, A. On the left side, we have 7 ones. So this has a total of 7. Okay, that has a weight of 7. 7 ones make 7. Okay. On the right side, we have 3 W's and a weight of 1. So, for our equation, we're going to look for the one that is set equal to 7. Okay? It has 3 blank, which is going to be our W, plus 1. So this is our correct matching. And go ahead and type W into that box. So now the equation is 7 equals 3W plus 1. I'm going to go ahead for number 2 and I'm going to write our equation in the form that we are used to so I can now solve it. So I'm going to talk about solving it using the hanging diagram. Okay, so if you don't need to use the hanging diagram because you got so good at solving equations with tape diagrams, good for you. You're doing great. You keep doing you and you keep solving them like you are used to. Me, on the other hand, I'm going to teach you how to use these hanging diagrams. So, first of all, our goal is to figure out what 1W is equal to. So, to keep my hanging diagram balanced, if I do something to one side, I have to do it to the other. So, I am going to start by getting rid of this extra 1 that's with my W's, because I just want to know what 1W equals. If I get rid of 1 on this side, I have to get rid of 1 on this side. So now I'm left with 3 W's are weighing the same as 6 1. Just the 6 ones. 6. So now I'm going to divide both sides by 3 to just figure out what 1W equals. So I'm going to group these. So that W gets those. This W gets these. This W gets those. Okay, so now I have successfully regrouped everything, and you can see that 1W is going to weigh the same as 2. So now I'm going to click out and it's going to get rid of all this, but I need to so I can type. So the first thing we did is we subtracted 1 on both sides. Then that is going to give me, I'm going to be left with 3W equals 6. Now from here we shouldn't have to. You should know 3 times what is 6, but if you don't, we're going to divide by 3. Divide both sides by 3. Okay, now when I divide both sides by 3, I am left with W equals 2, which is what we saw with the with the balanced hanger. Okay, now with this being said, you are doing B, C, and D. You are doing slides 5, 6, and 7. These 3 slides right over here. So go ahead, pause here, complete the next 3 slides, come back once you are ready. Awesome! Let's do these next 3 slides. B. Okay, on the left-hand side, we have 2 Z's and 3 1's. On the right-hand side, we have 5 1's. So the only equation that is set equal to 5, why is my thingy not working? Okay, hang on. And let's try connecting again. There we go. So the only equation that has 2 blank, because remember we gotta fill in our variable, and 3, and is set equal to 5, is our very first one. So shape tool, circle that first one, in the box, type out a Z, and let's go ahead and solve this. Equals 5. Okay, so first thing I'm going to do with my hanging diagram, again, my goal is to get rid of Z's. So I'm going to, did I say get rid of my Z's? I'm sorry, I meant get my Z's alone by getting rid of the 1's. Lord, I'm sorry, I am hungry and tired and ready to go to bed. So since I get rid of 3's, 1's on the left-hand side, I need to do the same to the right-hand side. I am left with 2z's equal 2. Okay, that's what I'm left with here. And then we can go ahead and regroup by dividing both sides by 2. We see that 1z is going to be equal to 1. So let's go ahead. We're going to show some work. So I have my equation. First thing we do is subtract 3. We would get 2z is equal to 2. We would then divide by 2 and get z equals 1. Alright, get this down. Let's move on to C. Okay. So, on this one, on the right-hand side, we have 3 x's and 2 1's. And on the right-hand side, I don't know if I'm saying my left or right correctly. I know this is the right side. I just don't know what I call this side. On the right-hand side, we have 3. So 3x's plus 2 equals 3. Only equations that equal to 3 is the second one. So let's go ahead. Circle tool. Oops. That works. Make it smaller. Okay. And go ahead and put an X in the box. Now, I'm gonna copy my equation down here. And, nope, equals 3. And let's talk about solving it. So again, I'm gonna start by trying to get my X's all alone. By getting rid of these 1's. Since I got rid of 2 1's there, have to get rid of 2 1's here. Now, this is where we get a little tricky. Okay, tricky. We have 3 x's equal to 1. So when I divide everything by 3, I'm dividing 1 by 3 as well. And I'm getting... Okay, there we go. Yes. Okay, so we have a fraction of a 1 that is going to be equal to our x's. Okay, I divided 1 into 3 pieces with each x being equal to 1 of our pieces. So, let's talk about what that would be. So first step is subtract 2. We get x equals 1. When we divide by 3, we're going to get one of 2 different answers. Either 1/3, nope, that's 1/4. Sorry, hang on. 1/3, because I divided our last one into 3 pieces, and with each x getting one of those pieces, so 1/3, or 0.3 repeating. Awesome. Yes, if you hear the growling, that is my stomach. I am starving. It is dinner time. Just trying to knock this out. Okay. Letter D. Last problem. Okay. We have on the left-hand side, all of these 1's equal 6. We have 2 y's. And we have 3. So, obviously, it's the last equation that we have not used. 6 equals 2 blank plus 3. That blank is going to be our y. So, circle tool, circle, 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 the dot. And type that y in. And that's write our equation down. And again, I'm going to swap it so it is in the form that we are used to. Now to solve this, my knee hurts. Hang on, let me stretch out. Okay. So to solve this, start by getting our y's alone by getting rid of these ones. So I'm getting rid of 3 ones on the left side or right side, which means I need to get rid of 3 ones on the left. And I'm left with 2 y's equal 3. So we're going to divide each side by 2. When I divide each side by 2, again, 3 is not evenly divisible by 2. So I'm going to end up with fractions of pieces yet again. So each y gets a whole 1 and half of a 1. So 1y is going to be the same balanced as 1 and a half. So let's go ahead, show our work using our equation. So we start by subtracting 3. We're left with 2y equals 3. Then, we would divide by 2 and get 1 and a half or 1.5. Remember, those are the same. 0.5 is a half. Good job, guys. We're doing great things here. Great things. Okay. Now, we're going to take it up a notch. But not really, because it's the same thing. I just now expect you to write an equation. Ha 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 ha. Okay, but still, pretty simple here. So, again, you have 4 hanging diagrams. A, B, C, and D. For each problem, we're going to write an equation and then solve it. So, I'm going to yet again do A. You're going to do B, C, and D, and come back to check your answers. So, our equation here. So, we have 7 on the left. On the right, we have 3 x's and a 1. So, you can put 7 is equal to 3 x's plus 1. Or write it the way that we are used to, of 3 x's plus 1 is equal to 7. These are the same, okay? One is just in the form that we are used to, which is the form that I am going to use to solve our equation. So, first thing I'm going to do, I'm going to subtract 1 on both sides. Stop it. Okay. So, I'm then left with 3x equals 6. Then I'm going to divide 3 on both sides and get x equals 2. We can do the same thing that we did in our hanging diagrams earlier. Subtract the 1 on the right. We would subtract 1 over here and it would become 6. And then we would divide both sides into 3 equal groups. 6 divided by 3, yet again, would be 2. Okay, go ahead and you're going to complete slides 9 through 11 now. And come back to me when you're done. Awesome sauce. Let's go ahead and go through these. So, B, on the left-hand side, we have 2 y's and a 10. And on the right, we have 31. So we can have our equation is going to be 2y plus 10 is equal to 31. Now, stop it. Gosh, I'm not even hitting the left. Okay, so again, I'm going to write down our equation. I am going to start by getting rid of the 10. Subtracting 10 on both sides. I can't see the keys because I'm laying down, but it's okay. So, subtract 10 on both sides. When I do that, I get 2y equals 21. And then we're going to divide by 2 on both sides. And if you notice, 21 is not evenly divisible by 2, so we're going to end up with a decimal. 21 divided by 2 is going to be 10 and a half, or 10.5. Okay, those are the same. I don't know why I keep doing fractions. I mean, we're going to have to do fractions in D, but okay. So, that is B. Let's go ahead and look at C. On the left side, we have 6.8. It is balanced with the right side, that is 2 z's and 2.2. So, you can have 6.8 equals 2x plus, I'm sorry, that's not an x, that's a z. 2 z's plus 2.2, or write it the way that we are used to. Again, I really don't care. Okay, I'm trained, so this is the way that I'm going to write it. And let's go ahead and rewrite our equation. We are going to start by subtracting 2.2 on both sides. And we are going to be left with 2 z's. 6.8 minus 2.2 is 4.6. Last, I'm going to divide both sides by 2. Hera, leave it alone. Stop. Thank you. Sorry, I'm going to divide 2 on both sides. I'm going to be left with z equals 4.6 divided by 2.2 is 2.4. So z equals 2.4. Cool beans. Next. Okay, last problem. Now a little bit trickier. We got fractions. But it's not that hard, I swear. Okay, D. On the left side, we have 4 W's. I know it is very hard to see, but that is 3.5. This is equal to 17 halves. That's on the right. So this is our equation. I'm sorry. I don't know why it is doing this. Go ahead, copy your equation down, and let's solve. First step, subtract 3 halves on both sides, and when we solve it, okay, we are subtracting fractions, so we need to make sure that the denominators are the same. They are. So the denominators, oh, can I move you? Yeah, I can. So the denominator, the bottom stays the same. It is 2. Now we just subtract the top. 17 minus 3 is 14. Now, 14 divided by 2 is actually a whole number. Okay, so 14 over 2 is the same as 14 divided by 2. And that is going to be 7. Just 7. No fractions left, just 7. So that is what I'm going to do for W equals 7. And then we divide both sides by 4. Now you can leave this as a fraction of, w equals 7 over 4. Or we can turn this into a lovely decimal of, what would it be, 1.75. Yeah. Right? Yeah, because 8 would be exactly 2. Okay. Hey, we did it! See, it seemed like a lot, but it's still shorter than an hour. We did it. Great job, guys. Okay, lesson synthesis. Go ask the lovely sub for a synthesis. Say please and thank you. And then let's go ahead and talk about it. So in this lesson, we worked with 2 different ways to show that amounts are equal. We looked at balanced hangers and we looked at equations. So here's an example. So this hanging diagram over here represents 3x plus 1 equals 7. Each box is worth 1. Each circle is an unknown amount. It is going to be, we're going to use x to represent it. So we have the equation 3x plus 1 equals 7. To figure out what one weight is equal to, we're going to start by trying to get the weights alone. To do that, we're going to subtract this little 1. And since we subtract 1 on the right side, we also have to subtract 1 on the left. So this picture shows those being kicked off of the hanging diagram. And now our new equation for this balanced hanger is 3x equals 6. Last, we can regroup the remaining weights into 3 equal groups. This is the same as dividing each side of our equation by 3. So I divide, you see I regroup these, divide by 3, okay, divide by 3. And we are going to see that one weight, unknown weight, which is x, is worth 2 of our 1 unit weights. So we get x equals 2. Okay, awesome. That's all I have for you today. Please get on GoFormative and do 6.12 cool down. After that, do 15 minutes of Edmentum. And then do 6.12 homework and any GoFormatives that just aren't done. Okay? Sound good? Lovely. Okay. Hope you guys have a great Wednesday, and I will see you tomorrow. Bye.